Hi guys, we're going to work on the vector problem from the other day where we had vector v, which had a magnitude of 4 and a direction of 30 degrees, and a vector u which had a magnitude of 5 and a direction of negative 40 degrees. Now I wanted you to do it both graphically and algebraically. So to do it graphically, what we need to make sure we're doing is we consider both the direction and the magnitude of each vector. I haven't drawn them to scale in the initial bit here, but we need to make sure when we're doing it graphically that we're taking both the reasonably accurate magnitude and direction into account. Lottie's just commentating as well. So I'm going to start by drawing V, and it's got a positive direction. Its direction is approximately 30 degrees, so it's approximately there. It's about 4 units long. Now remember, when we do vector addition, we draw the first vector, and then we put the second vector on by adding it onto the tail of the head of the first vector. So I'm going to draw U now, and it's got a negative direction, so it's negative 40, and it's a little bit longer than V. So I've tried to draw it there, a little bit longer than V, 5 units, and it's going down negative 40 degrees. So do you see that overall we're going to have a resultant vector that's got lots of positive x. It's lots in the x direction. See all this in the x direction. And overall it's got some positive y and it's got some negative y. See the negative y there's a bit longer. So overall, when we draw the final resultant vector, this is the resultant vector here going from start to finish. This is the resultant vector. When you take into account a little bit of positive y and a bit of y that's a little bit longer and it's negative, overall it's going to be a negative y. So that's how it looks graphically. And when we find it algebraically, we're going to see that we should end up with a really long bit of positive x and a little bit of negative y. So if we do it correctly, hopefully we get that when we do it out. Okay, let's do it algebraically. To be able to do it algebraically, remember we have to find the components of each. So the components of each, remember we had a look at this. The x component is equal to the magnitude of the vector. So I'll just use V for an example, and then cos of the angle, and the y is equal to the magnitude of the vector sine of the angle. Okay, that's the general thing. So if I start with V, we look at the I in the I direction. We're going to have a x component, so it's going to be 4 cos 30I plus 4 sine 30j. Now remember that cos 30 is root 3 on 2, so root 3 on 2 times 4 is 2 root 3 y, and cos of 30 is a half, so 4 times a half is 2. Now let's just think about this. It's a direction of 30 degrees in the positive direction, 30 degrees in the positive direction in the y here. So both of those are going to have, both the x and the y components are going to be positive, so that works out. That makes sense. As you're going through all of your questions, you should be looking at the solutions you get and thinking, does that make sense? And if you get something that's a little bit iffy, you've got to ask yourself, have I done something that maybe doesn't quite work? Okay, so let's look at U. 5 cos 40I minus 5 sine 40j. Now you've got to look and figure out what I've done there. Let's have a look. See, I've used positive 40 and positive 40. That's because, like what we do in Maths B when we're looking at the unit circle, I'm considering quadrant number 1. Even though it's in the negative direction, negative 40 direction, I'm just looking at the overall value of cos 40, because cos 40 and cos of negative 40, it's going to have the same number, but it might just be positive or negative. Now I know just by looking at the vector, if I've got in the negative 40-degree direction, I've got positive x, so that's why this bit here is positive, and now I'm in the negative sign direction, so that's why this whole bit here is negative. I just make it simpler for myself by considering the cos of the basic angle and sine of the basic angle. So I pop those in my calculator and I get 3.83i minus 3.21j. Now I think to myself, yes, lots of positive x and quite a bit of negative y, so that all makes sense. So then when we add them together algebraically, we can go v plus u equals 2 root 3 I plus 2j plus 3.83i minus 3.21j. And remember, when you add vectors together, i's go with i's, j's goes with j's. So 2 root 3 plus 3, 8.3i plus 2 plus negative, we could do a subtraction, that doesn't matter, either way, j. And overall we get 7.29i minus 1.21j. And you look to you say to yourself, does that make sense to the picture? I've got a really big positive x, yes, that makes sense in my picture, and I've got a tiny little bit negative y, yes, that makes sense. So this seems reasonable. Every time you do a question, you want to ask yourself, does this seem reasonable? So that's the question we had the other day. Hope that feels good. And I'll do some more practice questions for you soon. Okay, bye.